Okay, we're starting section 1.4. It's basically kind of what we've done the last couple sections. Basically just go over definitions and go over postulates now. Let's see, do they have any theorems in here? Looks like it's all, there's one postulate. Looks like they're pretty much all definitions and a couple postulates. So there's no theorems in it, but they all kind of look the same anyway, right? A postulate and a theorem kind of look the same, but a postulate, what's the big difference, Sam? What's the big difference between a postulate and a theorem? Somebody help him out. Hello, go ahead. Right, postulate is true. Well, theorem is true too, but a postulate is just accepted as true, and it doesn't need a what?
A reason.
Alex? Yeah, what's a word? What's a word that I used quite a bit yesterday? And I said that we're really not going to be doing much of, and you should be thankful for that. Zion? Proofs, that's right, okay? So a postulate, listen please. A postulate is a statement that's just accepted as fact, okay? We don't have to prove it, okay? But a theorem, it is fact, it's true, all right? But we are able to do what to it? We just said it. We're able to do what to a theorem that you can't do with a postulate? Prove it, that's right, okay? So a theorem, you can prove it. All right, just so that you know the difference. Let's do this one right here. To tell you the truth, I've taught out of, 3 or 4 maybe different geometry books, and I have never seen this word in those geometry books. So what is this thing right here that I just drew? That would be a line, okay? And let's put some points on here. I'm just taking this straight from the book, so if you look at it. Is everybody okay? Sure. If I'm drawing it up here, you should be drawing it right there. Y'all be drawing, right? Isn't that what you guys say? Not that kind of drawing, though, right? All right, here we go. Let's take a look at this. You have a line. You could name this line a bunch of different ways. Just somebody give me one super easy name for this line. Just say it out. I don't need you to raise your hand. Line K would be the super easiest way to name this, okay? Now, Ben, what'd you say?
I said DA.
Yeah, let's not just say DA. We would say what? Line DA. All right, you could say line AD. Keep going. Let's do some more. What's another one? Line what? Nobody's helping me out? Line what? I already said line DA. Oh, okay. So line BA, you can go the opposite way, right? Line CA, line AC, line what? There's a bunch of combinations, right? So you could name that line a whole bunch. All right. Settle down. I know that was super exciting, but you got to calm down. Okay. All right. So you can name this a bunch of different ways. What we're going to do is we're going to talk about a thing. Again, this is the first time I've seen this. It's called a half line. Okay. And if you think about a half line, right, because you can't really take a line and cut it in half, can you? Because the line keeps on going forever. So no matter where you go on this point, no matter where you go on the line, could be considered what? A half line. But that's not what they're saying. They're not really talking about the length or the distance of the line, because you can't measure a line, right? What's crazy is if I drew a line like super tiny, that's just as long if I drew a line really long, right? Would you agree with that? Because the super tiny one, does it have a beginning and an end? No, it just keeps on going in both directions. If I drew one that was really long, like this long right here, like 3 feet long, it's still the same length, isn't it? So taking half of the big line and taking half of the little line doesn't make any sense because the line keeps on going forever and ever. So this is not really saying we're taking a line and we're chopping it in half. That's not what this is saying. It kind of seems like it, right? Because it looks like half of a line, but it's not. It's called a half line. So it's basically, I'm not even going to have you write the definition down. It says it's a subset of a line consisting of all the points on a given side of a point of that line. So let's say the given point was B. So this one right here. Okay, I'm just going to put an arrow that's not a line. All right, so let's take this point right here. When we talk about a half line, we're just talking about the points on one side or the other. So, for instance, let me just see this. AB and AD. Yeah. Okay, so let's take a look at this point right here. Actually, let's not use that one. Let's use this one. All right. Do I have to write you guys up? All right. Because I will in a second. All right. So here we go. So when I talk about the lines, when I talk about a half line, I'm just talking about the line or the line that's on one side of point A and the line that's on the other side of point A. So if I look at all the points to the right, we'll say, in this direction, okay, of point A, this is how we would do a half line. So I would call it you could call it AB or you could call it AC. It doesn't make any difference. That A is kind of ugly. So let's just call it AB. But watch what you would do. You'd put just a half a thing and you put a little circle at the end of it, okay? It's different than something else we're going to talk about today, all right? But that would be a half line, all right? So it goes all the way up to A without touching it. So it's not really including A. It's talking about everything in this direction of the A. That would be half line AB, all right? So there, what's that? Because you got to know which direction you're going. So if I'm going from here and then going in this direction right here, I've got to know what point I'm going through. So you could call it AB. Yeah. You could also call it what? AC. Half line AC. All right. So you got to put a little open circle on that. You remember back in Algebra 1, you did graphs and you had greater than or equal to and all that, and you put an open circle. It's kind of like that. It's kind of like that, okay? Now, there's a half line going in the other direction of A. So how would you write the half line going this direction? So we'll say it's to the left. To the left. So we'd call it A what? AD, all right? Now, you would still, I believe, yeah, even though that looks like it's going to the left, our arrow up here for our symbol will still always go to the right. So it doesn't matter which direction that you're going on that half line, you still make your little arrow to the right, okay? Even if you're going the other way, all right? It just says you start at A because what if you're going up and down? There's no left and right, right? If it's really super slanted, you know, it doesn't matter which direction this picture is going, left or right, but if I start at A and I go through either B or C, you know we're talking about this part of the line, okay? If I start at A and I go through D, right here, you're talking about this part of the line. So our symbol is always going to be going to the right, always, okay? Even if my half line is going to the left. Does that make any sense? Okay. I tell you, I've never seen half lines before since I've taught geometry. I'm sure they exist. They're right here. It's a definition, but that's what we get. Let's go to something else that's very similar to it. It's very, very close to it, but this is definitely something that I've seen before, okay? And let's just make this look a little bit different. So we'll put a line right here, a line right here, and we'll put some points. Let's see what they use. So they use S, P, and R. S, P, and R. Yeah, that's good enough right there. Okay, now, watch this. This seems like it's the same thing as a half line. But remember, the half line, it went all the way to A, but did not include A. That's why you had that little open circle there. Okay? So you're talking about all the points on this side of A. It doesn't include A, but all the points on this side of A. This thing right here, what we're going to do, we're going to start at S. I'll tell you what, let's start at P. That's a better place to start. And I'm going to include letter P or point P, and I'm going to go in that direction. All right? So what would my letters be? I'd start at P, and I'm going through R. Now I could have 15 points, past the P right here. But you can just pick one of the points that it goes through. This happens just to go through one point that we've labeled. Now this thing right here, if it actually includes the letter P, we would draw an arrow. Now we don't really put a closed-in circle, but we just don't put an open circle, all right? And this thing is definitely something that we're going to talk about a lot, and this is a ray, all right? I've never talked about half lines before, but we talk about rays a lot, okay? So this is a ray. What's the difference between a ray and a half line? Well, the half line would not include P. The ray would include P. That's basically the only difference. Is that your question, Ben?
Well, wait, so like, if like, when you elaborate on what you mean that when you have fun like the point where you're at, like, like.
Yeah. So if I said ray PR, what does that mean? It means I start here. Here, let's do this. Let's do a different color. So that means I would start here, right, and then go in this direction. Okay, that would be ray PR. Do you see that in red? Okay. Now there's a bunch of rays that you could do here. Let's go back to the white color. There's a bunch of rays you could do. Now let me ask you this: is ray PR the same thing as ray RP? It's not, because what does ray RP do? It starts at R and it goes through P and it keeps on going in that direction. You see the difference? When I did lines, did it make any difference of whether it was line PR or line RP? Didn't make any difference because it just keeps going forever in both directions.
Ray can only be, it has to be the point has to be first.
Yes, the point where it starts, okay, because a ray doesn't have, it does have a beginning, but it doesn't have an end, okay?
So I've got a question. What would the difference between ray PR and half-line PR be?
The difference is that a half line does not include the letter P, all right? So if I said half line PR, that would mean everything in this direction from P, but does not include P. A ray actually includes that letter, okay?
So, if, so the half line, it'll be like, if, for example, P is not included, it'll be an arrow with the.
Yeah, if I said half line PR, I would do this, and then I'd put a little circle right there. That's when you're not including the letter P. All right, a ray does include this point right there. Okay, so you would write a ray like this.
The half line doesn't add its starting point.
Yeah, the half line doesn't really even start at a point because it starts just beyond letter P. What is just beyond? I mean, you could get super close, right? So there's really no starting point to a half line, but on a ray there is. We got to keep going. We got more to do. Okay. You could also, so we're talking about rays right here, so we're not worried about that. So what if I could go the other way? I could start at P and go the other direction. So what would I call that? Ray PS. All right. Is ray PR and PS the same thing? No, not at all. Is ray RP the same thing as ray PR? No, because ray RP would start here and it would go in this direction. You could write ray SP, but what does that mean? That means it starts here at S and it goes forever in that direction. You see the difference between a ray and a half line? We're going to talk about rays more than anything, okay? Yeah, I wouldn't even worry so much about a half line, tell you the truth, okay? So that's a ray. Let's skip a little bit. Okay, let's talk about, we talked about half line, let's talk about a half ray. Let me make sure. Actually, it's not a half ray. We call it opposite rays. We'll keep this picture up here. So what is an opposite rays? So what in the world is opposite rays? Well, let's start at P. We've already talked, we actually have them written up here, to tell you the truth. So if I start at P and go through R, that's a ray. Agreed? If I start at P and go the what? Opposite direction, right? So I'm starting at the same point, but I'm going in opposite directions. So what are these two rays? They're not the same rays, but they are what? They're opposite rays. They go in completely different directions, 180 degrees, right? Does it make sense? That's pretty easy, right? If you understand a ray, opposite rays, not that big of a deal. All right, let's keep going. Again, I'm skipping a little bit. Let's go right to this one because we're running out of time, like always. This is super important. We're going to be doing this stuff the rest of the year. So watch. One starts here. And let's do this. And then one goes like this. I bet you know what that is without even looking in the book. What is that thing? And it's an angle, right? And we're not going to talk about acute angles, but it is an acute angle. You're absolutely right. We're not going to talk about that just yet. We will eventually, for sure. But let's put some letters in here, and let's see what they put. B here, they put A here, and they put C right there. These two things, okay, intersect at point B. They start at point B. So what do you think an angle is made out of? Something we just talked about.
3 different points.
Okay, 3 points, but I could have 3 points and maybe not have an angle. But what's...
Line.
They're not lines, Gideon. They're 2 rays, exactly right. Look, an angle is made up of 2 rays. That's basically the definition of an angle, okay? It's made up of 2 rays with a common, we call this an endpoint. This point right here, they both come together. They both start at B. So we call that an endpoint. Oops. All right, so this point right here, point B, is called an endpoint. So let's break these up. If I asked you to write what 2 rays form this angle right here, what would you say? Ray what? No, you wouldn't start at A. A is not where it starts. It starts at B, right? That's the endpoint. Starts at B, right, and it goes through A, so that's 1 ray. What's the other ray that makes up that angle? BC, all right? Now, they're not the same rays, okay? We don't say they're equal or, no, they're not opposite rays because they're not going in completely opposite directions, are they? Right? Opposite rays basically form a straight line. Does this form a straight line? No, it doesn't, okay? That's this angle right in here. Now, this thing is called an angle. And there's ways to name the angle. Just like we name a ray, we name a line and all that kind of stuff. We can name an angle as well. And we have a little symbol for it. This is the symbol for ray. The symbol for angle actually kind of looks like that angle. So I just put like a little angle symbol like that. That means angle. And we always draw it like that. Okay, don't draw right, don't draw an obtuse. Draw a little acute angle. That means angle. Now, here's what's very important that you understand this. Again, we're going to be doing this the rest of the year. This is the first time you've seen it, but the rest of the year we're going to be going back to this. So the end point will always go in the middle. So what you're going to do, it has not rung. We still have 4 minutes. Oh no, it's Wednesday, isn't it? Oh, I'm thinking I had till 45 the whole entire time. Let's just write this down. Angle A, B, C. This is how we would name this angle. Or you could just call it angle B. You could call it angle B because that's your endpoint, okay? And there's another word for this when you talk about an angle, and we call that a vertex, okay? Well, yes, because they're points. Because these are points, so you would always label it a capital letter, okay? Because you're using the points on there. All right, well, you got off lucky. I'm not going to give you homework tonight. We'll finish this up tomorrow, and I'll give you homework then.